So, hi, I am Shivarshi, and today we were gonna be discussing about React hooks. Basically, what hooks are, why do we need them, what problems do they solve, and how do they go about doing that. So, okay. So let's see. Okay, these are the workshop rules. So, what are hooks? Rules for the hooks, and we are gonna discuss three React hooks, namely use state, use effect, and use rect. And we will look something about custom hooks as well towards the end of the workshop, and we will end it with an example of a tic-tac-toe. Okay, so what are hooks? So hooks are defined as hooks are simply just a function that let you hooks into a React state and lifestyle features from a functional component. Okay, so when you talk about hooks like that, it doesn't make much sense. Like right off the bat, if you have never heard about hooks, this definition of hooks might look some gibberish that it's hard to make sense of. So let's start with why do we even need hooks? And hopefully by the end of the workshop, after we are done with the talk, this definition might start looking familiar in some ways. Okay, so let's start with why do we even need hooks? So the basic requirement of hooks is that when a function runs, it can make some changes to a data, but when we rerun that function, those changes do not persist. So basically, when a function run, the changes made by a function are not persistent, and when we rerun the function, the data that were changes are resetted back to their initial state. And to prevent that from happening, to allow functions to persist our data, we are using hooks. Okay, so why do we even want functions to persist data? I mean, what good that will do? So in React, when we write a functional component, so this is what a basic functional component looks like. It is basically just a JavaScript function which returns a JSX, and the JSX which is returned by this function is what gets painted on your web page. So let's say there are some changes, the user interaction happened, and we need to update the component or the content that was painted by this function. So now what gets painted on the screen is the return value of the function, which is a JSX, and get converted to HTML and gets put on the web page. So we need a return value from this function, and the only way to get a return value from the function is to run that function. And when we run the function, the changes that we might have made gets like the changes don't persist, so we don't usually see any update on the web page. So that's why we want functions to be able to hold some state. And so here comes the hooks. This is what hooks allow us to do. We will see a bit in a moment how they do it and what goes under the hood. But basically, for using hooks, there are two main rules. First, you should call hooks from the functional component only. So this is required because that's how functional component or a custom hooks. So it is required because that's how React knows which component or which custom hook does the set of hooks belong to. And second is, which is a bit peculiar, it says that we should call hooks only on top level. Basically, it means that you can't conditionally call hooks. You can't call hooks in a loops or in if-else statement. So let's look at it. Why does it happen such way? So basically, to understand the hooks, we don't even need React. Let's just start with a basic function. So this is a simple function. Let's name it foo. And or bar, maybe we already have a variable called foo. So what happens is it assigns a value to a foo, it logs it, and then after logging, maybe it increments it, and then it exits. So what will happen when we run this function? We get a 0, which was the value of foo, and it prints it, it increments it, and functions run out. Now what will happen if I run it multiple times? So as we can see, every time we run the function, we are updating the value of foo at the end, but that change doesn't persist. Foo is always getting resetted back to 0. So we don't want that to happen. We want foo to have a persistent value. So one way to do is we can move it outside of the function scope. And now when we run it, okay, so now the value is getting updated as well as getting persisted. So basically now our function bar has a state. What if I want more than one state? Adding another state this way is way too cumbersome, and we don't want. Okay, so if you want to add more state, it's like React doesn't have an API where you can go and add a state on top level. You want to be able to add the state from the function, from inside of the function itself. Because if I want to use another state and then I have to go on the outer scope and add states there, that's not a good way of doing it. So let's make it so that we can add states from the function itself. So what changes we have made is we have initiated our states array as a value, and it's an empty array. And then from inside a function, we can specify how many states we want. So let's say we want an initial state and we want 3 of them. Let's initiate it to 11, 21, and 31. And now to access this, since this is a array, we can do something like let I equals to 0. And we can read the value of I. Then we can increment the value, and let's just increment the I as well. We have 3 states we have mentioned in initializing state, and now we are using those 3 states. And okay, so now our function have 3 states, and they have 3 states and they are stateful. Like for the first render we get 11, 21, and 31. For second render we get 12, 22, and 32, and so on. Okay, so one of the conditions that we saw when talking about the rules of hooks is that hooks should only be called at the top level. We can't call them conditionally. So let's see what will happen if we try to call them conditionally. So I'm going to do a math.random. And let's say I want to run this whenever this value is greater than 5.5. It didn't even get run once. Okay, it got run. Let's rerun it. So we have a clear output this time. So for the first condition, for the first time it did not run. So what happened? The output of 31, which we were expecting at the with 3 on here, gets shifted. Instead of 31, we are getting a 21. So if we run a hooks conditionally, whichever hooks doesn't get run, the value of the previous hooks gets shifted ahead, and this effect is like it passes through every hook. So if you miss a hook in the second number, so every hook after that gets shifted ahead one step. And after that, when we see it did get run, so when it got run, the value for the 2 which we expect here was correct, but the 3 then get misplaced. Instead of 32, it's printing 31. So this was the very oversimplified version of what hooks does. But 2 things that we can take note from this example, and which is almost similar to how React handle things, is first, to make a component stateful or to make a function stateful, you have to put its value somewhere outside of a scope. Here we have used a global scope. In React keeps an internal state, and it manages which state belong to which function. So basically, the value which are stateful are not defined inside of a function. They are kept outside, And second thing is React hooks need to be called in the order, because if we mess up the order or call them conditionally, the hook that we are expecting gets shift in the position. So after that, we can define what actually hooks are. So hooks are basically anything which lets you keep a data into this values array. So when you rerun the function, that data or the changes made to that data persist. So from here, we can define hooks as anything that lets you keep data into a value array from a function. So why do we have so many hooks then? Like for example, today we are discussing use state, use effect, and use react, and all of them do a very same thing. They let you keep our data into that values array. So why do we need so many hooks? So it turns out that when you are keeping a track of some sort of data, you expect to do something when the data changes, and this all hooks differ in what they do when the value they are keeping track of changes. So for use, let's start. Okay, so for basically use state, it re-renders the UI. For use effect, it when the data changes, it's run a set of function or a routine that you have provided in advance, and user just holds a value. It doesn't do anything. So let's start with use state. So this is the syntax of use state. So use state, you can define a state in a React function by use state and passing it an initial value. It returns a value, returns a tuple. For first one of is a value and second one is a function. Basically that acts as a getter and a setter for the particular state. And whenever this state is updated, the React component is rerun, means is re-rendered, and whatever the changes that are made are painted to the UI, updated in the UI. Okay, so this begs the question, what will happen if we don't use state? So as we saw in the previous example, the first thing that will happen is so in case of use state, first thing that happens, it doesn't trigger re-renders. So we can see that. So this puts a 0 on to our UI, and it puts a button to handle an increment function, and this is a handle function. So what this function basically does is declare a variable called counter, and it returns a UI where there is a h1 which shows what the value of counter is, and there is a button which on click runs a click handle function. And what click handle does is it increments the value of counter. It also console logs it. So let's increment it. So as we can see, the value of counter is getting incremented, but it does not update in the UI because changing of a local variable does not trigger a re-render. To trigger a re-render, we need a state variable. And the second thing that would happen if it triggers a re-render, we saw that the local variables cannot hold their state. So let's say if I okay, so I have a custom hook which forces a component to re-render. Let's import it. And whenever we click the component, let's force it to render. I'm also going to put console log here, so I know the app re-rendered. console.log. So app render, and now when we increment the value, we can see that value is incremented, but since the app is getting re-rendered, the value gets set back to the its initial state what we set is. So we need a state to update an UI on the change of an value. Okay, so let's see, the to change in state we need a set state function, and set state function can be run in 3 different ways. So let me just make a counter state. Just give me a minute, please. Okay, so here we have a counter function which is a state initialized with 0, and it paints out an UI where an h1 displays a counter. We have a function to reset, function to increment, and function to +3. So set state function updates state in 3 ways. When we have a new value which doesn't have to do anything with the previous value, it's just a value. So in cases like a reset, when you want to set a counter back to a 0, we can do the set counter and we can pass the value which you want to reset it to be, which is 0. In case of an increment or derived value, it is advised to use a callback. We will see in a while why it's so, but we can do just like that, set counter, and we can use counter +1. So when we increment, the values get incremented, and when we reset, it goes back to 0. But let's see what happens if we try to increment set +3 in the same way we did a increment function. So if we do this, and let's do it 3 more times. So it's still only getting incremented by 1. So why this happens is because the set counter function are ran asynchronously. So if I try to console log the value of counter between every set counter function, it's gonna be same. So as we can see, the CC value which we marked here is getting printed 4 times, but it doesn't change. So value of set counter only changes after we have completed the function. So they are incremented asynchronously. So if you want to do something like this, we set counters also accept a callback, where a first value is always the previous value of a state, and what we return from this function is a new value of a state. So if we call it with this like 3 times, okay, now so the state is now updating in a +3 fashion. It always increments with a 3 count. And another case is when we are trying to set state of an array or an object. So let's just quickly make this state, instead of an integer, object with a value of 0. So, and I'm going to rewrite the increment function for it. There's probably some error there. I will look into it in a moment. So we saw that when we want to update a state based on a previous state, we should use a callback method, take a prev, and return a updated state. So if I do prev dot value and update it to, let's say, prev dot value plus equals to 1, just give me a minute, I'm gonna debug it why it's doing something like that. Okay, so you can, yeah, so if we are using a objects or an array and then we increment a function, I don't know why it's working like that. Okay, probably we can come back to this example at the end of the talk. It will otherwise take the entire time to debug it. Let's just move on. So next we have a conditional rendering. So what conditional rendering means, since we now have a state, we can conditional render something depending whether we want to show it or not. So we can do a conditional rendering in 3 types. Either we have a ternary operator. We use a ternary operator when we have a value, and depending on what it is, we either need to show one thing or another. We can use a double AND operator when we have a value, and depending on that, either we want to show something or we don't want to show anything. And if else statement, and we can use an if else statement, but you don't find it used much often because the and ternary operator are inline. They forms a JavaScript expression and they are allowed in the JSX. But if you use an if else statement, you have to write a 2 return statements. I have example for that, and let's see. So we have a conditional render here, and let's first look at this if else component. So what if else component is, or first let's look at the expression component. So what expression component is, we have a state which is show, which is a boolean. It can be either true, it can either be false. And we have a return statement, we have a question, we have a answer, and we have a show answer button. So what conditional rendering basically means is, so if the state value of show is true, based on whether it's true or false, we need to switch between hide and show. So right now we have started with the false. So when the JavaScript evaluates this equation, it sees that show is false, and therefore it's render this out. So it comes out to be show answer. When you click on it, the show turns to be true and it becomes a hide answer. And this is a double AND operator, because when the show is true, only then we want to show an answer. Otherwise, we don't want to render anything. So this is how ternary operator works. And if the same thing you want to do with an if else statement, since the if else statement are not JavaScript expressions, so you can't put it between a JSX. So you need to return 2 separate return statements. One where you are showing a hide answer option, another one where you are showing a show answer option. So basically they both have the same functionality, but the if else method is much more longer and it's usually discouraged. You won't find it very often being used. And so the next one is where the states are held in the JavaScript. So we discussed initially here that if you want to make a function stateful, instead of putting a declaration, instead of defining a value into a function, we define it outside, we keep it outside the scope of a function. So how React handles the state is, it keeps internal state of all the components, and it maps it to a component. And how it maps it, it sees what type of a component it is and where in the UI tree it's located. So basically what that means is, if we look at this example, so let's see what we are doing in this function is we have a test function which is simply returning a button which is you it has a state which is an integer, and it is returning a button which increments the integer by 1, and it shows what state of the what the value of the state is at any moment of time, and it takes the children and renders out the children between the button and the state statement. So let's so we have a function with a toggle statement with toggle state, which is a boolean. So when we click on a switch button, the toggle state switch between the true and false, and depending on what the value of toggle is, either this text component gets rendered or this text component gets rendered. So first text component has a div which says I am a first component. It has a strong and a break element, line break, and the second text component just have a paragraph saying I am the second component. And when I click on the switch, so it is just conditionally rendering between this and this. So what will happen if I am rendering a first component and then I increment the state of the text? So you can see the state of text and it is 6. Now we can increment it further. And now when we switch, we see that even we are not rendering this component, we are not rendering this component anymore. This is the component which is getting rendered, but still state persisted. So why does this happen is because how React keep tracks of the state. So React sees that the position of which with this both components are rendering is same, and since they are both the type of text component, React cannot differentiate between the two components. So it thinks of both of them as the same component. It also drives home the fact that key states are not stored in the inside of a functional component, because we are doing the different components here, but state is stored in the React and internally, and it gets persisted here. So if you ever get run into this problem like this, you can just pass each of them a key prop. So this helps React differentiate that these two are indeed a separate component. And when I do something like this and refreshes it, now we can increment the state, and now when we switch, we get the expected behavior that state is resetted back to 0 for the second component. So second hook that we are going to discuss is use effect hook. So what use state hooks does when the state that is keeping track of changes is that it re-renders the UI. What use effect hook does is it keeps a set of dependencies at the state, and when those get re-rendered or when those changes, it runs a function. Basically, you can pass it any routine or function that you want to run in case of a state that's keeping track of changes. So there are a few things to note about use effect hook is it runs after the rendering. So use effect, the function that you put in the use effect hook runs after the function has completely rendered. It returns a return type, which is called a cleanup function. We will look about it in a bit. It's basically used to clean up any side effects that you might have used or set up in a use effect hook. And then we have a lifecycle method. So basically, when there were a class components, you have a lifecycle method like component did mount, component did update, and component will unmount. So instead of these lifecycle methods, we use effect hook in a functional component to emulate the lifecycle methods. And by definition, use effect hooks are used to set up a side effects. What are side effects? Side effects are anything that React directly doesn't handles. Like React handles the syncing up of a UI with the changes in state. If you have anything other than that, like calling an API or setting up a subscription, you can do it in a use effect hook. So this is what a use effect hooks look like. You call a use effect hook and it takes us to two things. first of which is a function that you want to run when its dependency changes, and second is a dependency array in which you can pass under what circumstances or on change of which dependencies should a use effect function run. So there are three ways you can do this. If you put an empty dependency over here, so the use effect function will run only the first time when the component is rendered. Basically, it runs when the component gets mounted to an UI. If you didn't put anything in a use effect function, it runs every time the UI is updated. And if you put some data into its dependency, use effect function run whenever the data in the use effect dependency is updated. And the return type for the use effect is a function. So only thing you can return from a use effect callback function is another function which acts as a cleanup for the previous function. Let's say you call and you set up a subscription or you edit an event handler. You need to remove those after you have unmounted your component from a UI tree. So the return function from the components and return function from the use effect callback function take care of that. So let's look at an example for an use effect. So here we have a single component called app, and it has two states. State 1 and state 2 both are integers initialized with 0. And then we have what UI is there is h1 showing the state 1, and we have a button which increments it by 1. We have state 2 and a button which increments it by 2. And we have a hide button which demounts the component and again mounts it back on an UI. So let's see what happens when first the component is mounted. When first we mount a component, the use effect without any dependency array, as you can see there are no dependency array runs. The use effect with empty dependency array runs, and the use effect, any kind of use effect, either have a dependency or not, runs on the first mount. And now we have a use effect with a dependency of 1. Let's increment a 1. Let's see what happens. So when we increment the 1, first the return function from the node app means the use effect without any dependency runs. So this is a cleanup function. It cleans whatever the effect was set in by this use effect function. Then the return function from the use effect function where 1 is passed as a dependency run, and after that the use effect callback function, this function from the with the use effect without any dependency runs, and then the callback function from the use effect with the dependency of 1 runs. Same case happens with the 2. And when we unmount the function, all the return functions from all the use effect runs. Like, so basically on the mounting, all the callback runs. On unmounting, all the return functions from the use effect run. And whenever under certain circumstances certain use effect wants to rerun again, it first runs it cleanup function, its return function, and then it runs its callback function after that. And lastly, our last hook for the day is useref hook. So useref hook is very similar to useState hook in a term that it stores a value and lets you use it, but useref hook doesn't trigger a re-render. So in essence, useref hook doesn't do anything. It just holds a value. You can use that value anytime you want. So what are the most popular use case for useref is when we want to handle DOM manipulation. If you see, there is a case where you want to update a DOM, so you can pass a DOM a ref, and that ref acts as a functional handle or a programmatic handle over that component. Similarly, we also use this when we want to keep ID, or when we want to, like, if you are doing some sort of animation, or you are doing some sort of set interval, set timeout thing, so it returns a cancel animation state which we pass to a cancel interval or cancel animation. We usually use ref to keep hold of it. I might also have an example for this. Just give me a minute. So here in a function we are creating a input ref. So to create a user ref, you just have to call a user ref function. You can also pass it a initial value, anything that you want to be assigned, or you can just call it and it will be assigned as null. So what a user ref return is a frozen object. So this input object, so this is what a object looks like. It is an object with a single value, with a single it has a single value state, a single value called current, and you can only read or write to it. You cannot add more values to this object. You cannot get rid of a current object. So here we have an input ref, and how we can use it to manipulate DOM is when you define anything, you can pass a ref. So okay, in the last workshop we saw that the React components have two special properties on it. One was key and another was ref. So this is how ref is used. You can pass a ref to a ref, and now this ref's current property holds a reference to this component. So we have a button here on click of which it runs a set focus function, and what set focus does is goes to an input ref, and on its current property it calls on focus. So if I click on the focus, it focuses the text input. So there can be a large amount of text here, and you can use it to focus on the input. So this is the most popular way the use effect hook is used. And now we can also discuss about the custom hooks. So hooks can be used either in a React component or a custom hooks. So we just custom hooks are basically just hooks, means they are a React component, but you don't render an UI for it. You just take out the logic. It will be easier to see with an example. So we have made a counter component in the last workshop as well, and I think in today's workshop we have made some sort of counter component. So instead of writing counter component multiple times, what we can do is we can set up a counter component like we always do. It has a count state, it has a function to increment it, to decrement it, to reset it, and instead of writing an UI for it, you can return these functions. You can return this function, and then you can utilize it in a separate, you can utilize the return value from the okay, and also they should be called as a use counter. Okay, so inside of a function, now whenever we need another counter, we can just call a use counter hook. It returns a count, an increase counter function, a decrease counter function, a reset counter function. And then in another function, we can define the UI for it. So basically it shows a count, a button which on click increases the increase count, on which another button which on click calls a decrease count function from the custom hook of a use counter, and similarly reset function. And with this we can use counter anywhere. Instead of rewriting the entire logic, we can just call a use counter hook, and it gives back us give us back the value of count, increase counter, decrease counter, and reset counter. And the last concept for the day is the one-way data flow. So what happens in React is there is only one-way communication allowed. So parent can communicate with the child via the props, Parent can communicate to child via props, but not the other way around. So when we have a two sibling components which want to communicate to each other about their states, what state they are in. Like here we have a and B, they are a sibling UI, and if they want to communicate with each other, they can't do that. So to facilitate such sort of communication, what we do is we raise their UI. We raise a UI to a parent component. And so when we raise a UI to a parent component, now the C has the knowledge of state of both component A and component B. So let's look at an example for this. So we have an accordion component. It has an open state and a set of, it has an open state, which is a Boolean. It can either be true and either or false. And on clicking on the accordion, it switches the open state between true and false. And depending on if the open is true, it renders this paragraph. And if it's false, it doesn't render the paragraph. So we have always seen this accordion component like this. So what if I render the multiple instances of it? I need to wrap it in a fragment. So if I render the multiple instances of it, now each accordion, what happens when each accordion manages own stated, you can open multiple accordions at a time. So we can have a multiple open accordions. So if this is what you are going for, well and good, but we might all have seen an implementation of accordion where you click on, let's say if this accordion is open and I click on another, it first closes this one and then opens this one. So to do something like this, we have to raise an state of an accordion component to a parent function from where it can manage which accordion to open. Let's now look at that example. So in this example, we again have a similar accordion component. Actually, it's almost the same accordion component. The only difference is now we have a accordion parent component, which is holding a state. Now, as you can see, the accordion component doesn't have any state of its own. A parent component is holding a state and which can grow from null 1 to 3 depending on which accordion we want to open. So we have a helper function called render accordion, which returns an accordion. It returns which accordion is open, which is passed to a accordion child accordion by a accordion parent. We have an ID to an accordion because since now parent is maintaining all the children, we need a way to differentiate between them. And click handler, what will happen when we click on an accordion? So what it does is check if the accordion that is clicked was open. If it was open, it closes it. If it was not, it opens itself and closes any other accordion that was open. And now when the open comes, it checks if the open accordion is equal. It checks equality against its ID. So basically, if this is an accordion with an ID 1, it checks if it checks the value of an open accordion, which is probably might be null 1 or 2, and it sees if it is equals to ID, it opens it. And this way only one accordion can be open at a time because open takes a integer which can be 1 2 3 or null. So now when we click on another accordion, only one can be open at a time. So yeah, when we want to communicate about between sibling components, we have to raise a state to a parent component to facilitate such communication. And for the last part of the topic, we saw through quite a lot of concepts in this talk, and let's bind them together in a single example of a tic-tac-toe. For the example, I would like to hand over to Ameed. So Ameed, can you please take the example?
Thank you, Shivarshi, for explaining about hooks. Now let's try to build a tic-tac-toe. So I'm going to share my screen. So as we all know, in our previous lecture, we learned about how we create the how we got the root element, and in root element we have a function create root, and we pass the root element in that particular node and function, and it renders our component. So we are rendering our app component right now, header from app. So TikTok Toe is a game, as a board game. Who those people who don't know what TikTok Toe is? So it is a two-player board game which has a spaces of 3 by 3 matrix, and people used to fill the fill the spaces with the crosses and zeros. So let's try to build a board first. So this is the I have already created. So let's function, and it renders. Okay. So instead of string, we are going to paint our board, and we are going to import it. So his board is our one. So board contains square boxes. As we all know, we can create a square boxes. I've already created a square function file, and we are going to put the square. It's nothing but a button which has a class name square, and we are going to render it on our board. And we are going to import a square as well. This should we can see our square. So we need 3 by 3 square, which means we need 3 rows of squares and 3 columns of that. So what we are going to do, we can create either many squares hard coded, or we can create a state of which has we can create an array, and we can loop over the array and show the squares. So we need to import the use statement. So here's a square array which has a 9 element in it. Initially, we are filling it with the null values, and we are going to map over it. So as you all know, if we want to execute the JavaScript, we need in between JSX, we need to put the JavaScript between the curly braces. So square.map, and each will be giving us the square, and we are going to render it, as well as we want the index of it, because we are not manipulating the uh, square, so we can use the square as a key, and to return it. So we need to add the class, I guess, and for class name, I'm going to use yeah. So we get our board ready, and we need to pass the value. For now, we are passing the index just to show everything is going smooth. So we are taking props, and mm, so here we are getting the props value. So what we need to pass the value is the square of that particular index. So this is our square. Now, if we click on any button, it doesn't happen. So we need to create the handle function for it. So we are going to create the handle function. every handle function, we will pass our index to it. So okay, and we will pass the index. So square, we can even pass the square. So whenever we click on it, we have passed the on click function. Now we need to handle that handle function we have passed to the square in the square component. So whenever we click on it, we have a props dot. So we will run this on click functions whenever we click on the test square boxes. So we need to create. Now we are going to set the squares, and we have we as we all know that it has its drive state and it can accept the callback, and the first value in the callback is its previous state. So we are going to do state map square. So what we are going to do in this is, so first of all, we need to check the index and the I is equal. So if we take the index here, and we will check if index equals to I, or we can use the ternary operator. We are going to put x, otherwise we are going to return the previous state. So whenever I click on it, we need to return the previous state. If index is I, we are passing the index value. If index I, we are going we are on props, we are passing the on click function, and in handle click function, we are calling this handle click function, which sets squares and it returns the previous state. And it returns the map, right? Returns the at debug it. We will return the x instead in that. Previous state dot map. First of all, let's check we are getting it in handle function. So we are going to log it. Click on. Okay. So our handle click is not getting called uh, on click function, and instead of, so what if we click on it, props dot we are passing so there's a on. So what we are trying, we are the K was capital, I guess. So that is why it's not calling it. So now we are, if we click on it, we are going to grab x, and we can now index if is I, then we can add the x, otherwise we will return this y. So if we refresh and if we click on it, and now it will be handling each block. So we are going to pass the key as indexes. So right now it's only printing the x value. We need x and y, so let's create a handler for it. So const is x next, because we want to show x alternative times. That x is x. X. And if x next, we are going to use ternary as well. So if x next is true, we are going to use x. Otherwise, we are going to use 4. And we also want to update the next every time we click. Or next will be previous value, and it will return the pudding. If you click on x, now we get 0. Now we get x. Now, so it is perfectly working. Now we need to check if uh, someone wins or not. So in order to check, whenever the user clicks on that, we need to check if the user is win or not. So as Shivarshi told us about use effect with the dependency, and we need to pass the dependency to it. So what we want every time the square changes, we need to run the use effect and check if the user has win or not. So we can check on winning winner person. Calculate calculate winner, and we will pass our squares in it. I think we need to import it. So yeah, we'll go. So if the winner has, what we are going to do is winner. We need to add one more set which keeps track of the winner. Winner set winner. Each late will be none, and we can set, if we have one winner, we can set the winner. And now we need to show if the user has win or not. So we need to add that in the our component to display if the winner. Winner. If we have winner, we can say that winner is, and if we use the template, otherwise we can show none. So the calculate winner nothing is does nothing, but we have this that um, on which the winner decides. If we get the same value on every on these given elements, we will assume that the user is winner. So if we get same value on 1 2 3 1 2 3, so we will assume that the we will know that the user has been the game. So let's try to build it. So no one is winner. Yeah, X is winner. We got the diagonal here. So let's create a reset function button as well. And with the reset button, we can uh, shift to the Q&A reset thing. In reset, we will we want all the squares to be null. Okay. And we want X to be true. We basically reset all the and chat functions, and the winner should be null. So we need to create a new button at the bottom. Let's create it. Element reset. So let's click on it. It will reset. So this is a basic tic-tac-toe example. The winner is. Thank you guys.